While our last video was on the chemical composition of igneous rocks, on this video we're going to focus on the textures of igneous rocks. And the texture is just the size and the shape of the different minerals that are interlocking inside of this solid igneous rock. But texture is going to be important because it's going to tell us how quickly or how slowly it cooled off by the size of the mineral grains. And remember that quick cooling produces small minerals because they don't have enough time to form larger ones before they turn into a solid. Whereas slow cooling that happens over a long period of time is capable of producing much larger mineral crystals. In total, we have 6 different textures for igneous rocks. And our first 2 are fine-grained and coarse-grained. And these are just telling us how big or how small are each of the individual minerals inside of these rocks. So our upper image is a rock called rhyolite, and this is a good example of a fine-grained texture. These are the igneous rocks that cool off very quickly from lava at the surface. Because the lava is extrusive, it's exited the earth, it's escaped those really high temperatures. So it's going to cool down really rapidly once it's exposed to our nice 70-degree atmosphere. So with these, we need a microscope in order to see the minerals inside of them because they're so small because they cooled off so rapidly. But the bottom image is the exact opposite. Here we have a coarse-grained texture. The minerals are large enough that we don't need a microscope, we just need our eyes to be able to see each individual mineral. And when we see these large, coarse-grained minerals, it's telling us that they took a long time to cool off, and that they cooled off inside of the earth where it's still very hot. So it took probably hundreds, if not thousands of years for it to cool off and solidify into a solid. But our third and fourth type of igneous textures are called porphyritic and vesicular. So a porphyritic texture, I have no idea where this word came from, but it means that it has 2 different textures to it. So it's basically going to be a combination of our fine and coarse-grained textures like we saw on the last slide. So if we look at this upper image, we can see that there are these large white minerals that are separated by a bunch of kind of tannish, orangish minerals. So here we have both coarse, the white minerals, and fine-grained minerals, the tan. And this is telling us that it cooled off in 2 different stages. It started off cooling down very slowly deep inside of the planet, where these large white minerals were produced. And then, generally, we had a volcanic eruption. It's going to take all of this magma and release it to the surface as lava, where now at the surface it's going to cool down and solidify very rapidly as these small tan crystals surrounding it. So porphyritic just tells us that we have 2 stages of cooling. It started off slow cooling deep inside of the planet, and then after a volcanic eruption, the rest of it cooled off very quickly at the surface. But our fourth texture is called vesicular. And a vesicle is just a hole. It's a space. So a vesicular texture is just an igneous rock that's full of holes. Think of it as like Swiss cheese. And the way that these vesicular textures form is from lava cooling down fairly rapidly at the surface. Remember that inside of magma it has dissolved gases. And just like if I pop open a can of soda, those gases will escape over time. With lava cooling down, the gases escape as well. But if I can force that lava to cool down really fast, it's going to trap those gas bubbles inside of the lava. And it's going to cool so that each of those gas bubbles turns into an air hole within the rock. And this is just called a vesicular texture. It tells us that the lava at the surface of our planet cooled down so rapidly that the gas bubbles did not have time to escape. It probably cooled down in a matter of minutes, if not hours. Our final 2 igneous textures are glassy and pyroclastic. With a glassy texture, this is the igneous rock that forms instantaneously. So thinking about super hot lava dripping directly into cold ocean water. It's basically going to shock that lava into becoming a solid. It's going to literally from one instant to the next go from a liquid lava to a solid rock. And because this is instantaneous, the different atoms inside of it won't have enough time to form that repeating internal crystalline structure. Instead, they're just going to be wherever they were when they're frozen to place. So these glassy textured igneous rocks are really unique because they don't have any minerals inside of them. Because remember, to be a mineral, it has to have that orderly crystalline structure, and these do not. And our sixth and final type of igneous texture is called pyroclastic, and this is a fragmented texture. These form when we have really explosive volcanic eruptions, where the volcano is literally going to explode into millions of small pieces. Because that explosion is going to produce a lot of heat, those pieces are going to kind of be melted back together as a new rock. And this we just call a pyroclastic texture. And to be honest, these aren't very common unless you live in an area with volcanoes. And thankfully we don't. So we're not going to focus a lot on pyroclastic textures. Just know that they form in really violent volcanic eruptions. So looking at the different types of igneous textures are going to tell us two important things about these igneous rocks. The first is going to be where did it form, and the second is going to be how quickly it formed. So as we move around this diagram, our glassy igneous rocks form instantly at the surface from lava dripping into water. Second on the left, we have our porphyritic, the one with two textures, both fine and coarse-grained. This tells us that it has two stages of cooling. It started off cooling slowly inside of the earth. Then after a volcanic eruption, the rest of it cooled off quickly and at the surface. The bottom left, we have a coarse-grained texture. These are the minerals are big enough we can see with our naked eye. So this tells us that that magma cooled off incredibly slowly deep inside of the earth, giving it enough time to form really large minerals. On the right-hand side, on the upper right, we have a vesicular texture. These form from lava cooling off in a few hours at the surface. It cooled off so rapidly that the dissolved gases did not have time to escape the lava before it solidified. We also have pyroclastic in the middle on our right. And remember, these are the ones that are broken apart in an explosive volcanic eruption that produces a lot of heat that kind of melts those broken pieces back together. And then finally, we have our fine-grained textures. These form very rapidly at the surface, and we need a microscope to see the minerals because they formed so quickly that they didn't have enough time to grow any larger.